Hi, if you've not met me before, I'm Patrick Mills. I'm the founder of Amino Tech Research and Development and also the co-founder of Biosource Baits UK. My passion for the last 20 years has been amino acids and how they stimulate fish to feed. And what I've got here is just literally several slides showing you how that works. So yes, 20 years of research condensed into about 5 minutes. So without further ado, let's take a look at our presentation, Amino Acid Fish Feeding Stimulants. Okay, so there's the first slide, right? Now, the relevance of that bed of garden eels will become apparent in a moment. Okay, so let's get going. So, bottom line is, what I've got here is a blank graph essentially, right? So the left axis, the y-axis is stimulatory response. So as you feed fish food with amino acids, they leak into the fish's environment and attain a certain level of concentration, and that's correlated with a certain level of activity. So the left or y-axis is the perceived stimulation of the fish, and the horizontal x-axis is the concentration of amino acids in the surrounding water. Now it's in chemistry units of moles per litre, and where it starts, 10 to the minus 7, 1/10,000,000th of a mole per litre, in real terms is approximately about 1/10 of a grain per litre. So if you think of 1/10 of a grain of salt dissolved in a litre of water, it's a really small amount for the most potent amino acids. All right, so let me click through a few slides here. So that's a classic response curve. Now, the blue line there is for potent amino acids such as lysine in this case, or valine. There are a bunch more. If you're a carp angler and you've read Kevin Maddox's Carp Fever, you know of his league table of amino acid potencies. And lysine is one of the kings, all right? It's one of the big ones. So there's lysine as an example. Now, what the takeaway from this is that stimulatory response, as you can see from the steepness of that curve, stimulatory response takes off very quickly and then plateaus out when we reach what's called saturation, which we'll talk about in a moment. Okay, so it's a very unique shape, all right, which has some problems which I'll discuss in a moment, but that's the shape of the response curve for a strong amino acid. Now, if I put in a weaker one, if I go to the kind of the less potent ones in Maddox's table, betaine is a classic. Betaine, which is often used in fishing and aquaculture as kind of a benchmark of stimulatory effect for a reason. It's actually quite low on the potency scale, so you don't get much bang for the buck in terms of stimulatory response. But what you do get is a delayed response. So it's not as potent. So if you look at the graph there, it can be 10 or 100 times more concentration of betaine is needed for the same response as something more potent like lysine. So they don't make great products necessarily because you need so much more of them. Okay, so rather than putting in 3 milliliters, you're putting in maybe 30 or more milliliters of product, which is not optimal for, you know, a fishing or application in aquaculture. All right, now, oh, there's the garden eel. Back to the garden eel. So like when you plot all these against each other, it looks like a bed of garden eels. That's my little joke. I know, not funny. All right, keep going. All right, now, turns out, now this is key, all right, and we'll see more about why on a microscopic level in a moment, but when you dose amino acids with fish, they start off searching, and then they go through an optimal level of stimulation, and then they overdose. They get kind of like a little bit, kind of like drinking 6 cups of coffee. They get a little bit tweaked up a little bit and then just move away, all right? So an overdose of amino acids is in no way harmful to the fish, but it will result in them eating less and a much diminished catch rate. So what you've got to do with amino acids, and you can see it there, you've got to keep it in that Goldilocks zone of optimal stimulation, which has been the Achilles heel of amino acids since people started using them, and we'll see why. So click again, and that's why. So because of the steepness of the curve through the optimal range of stimulation, the effective concentration range, so look where those arrows hit the bottom axis there and the kind of the orange width arrow, the effective window of stimulation is very narrow. So not only are you down there at 1/10 of a grain of amino acid in a litre, but you can only be off by about, you know, another 1/10 of a grain. So you've got that tiny little window way down there in concentration where this effect is best observed, right? So that's almost impossible to pull off in a fishing situation or an aquaculture situation. And this has always been the problem, as I mentioned, all right? It is alleviated somewhat, and this kind of helps explain why betaine, although it's much less potent, is a little bit more preferred, because it's a little bit more consistent. So with the steepness of the curve reduced for a less potent amino, the window of stimulation is slightly broadened. So you can have a little bit more fudge, but you got to use a lot more amino acids. So that's the catch-22. Potent amino acids, you need less, but the window is very narrow. Less potent amino acids, you may need 10 or even 100 times more, which is impractical, but the window is much broader and more everyday user-friendly. Okay, so that's been my dilemma. I've been thinking about this for 20 years. And how do you actually solve this problem? Well, that's really what I'm here to talk about. So let's go in, take a look. Now, here's the graph again. Okay, so I'm going to show you how we solve this problem. Right, so there's our kind of dilemma graph, right? So the vertical line in this case is what's called saturation, which I'll talk about in a moment. And you can see on the left, we've now gone to a microscopic description. So it turns out that the level of stimulation we see in the wild and in the fish tank is almost directly correlated to the fraction of amino acid receptor sites occupied. Now, this is how it works for literally any drug. It's called the therapeutic range, right? So you take an aspirin, between 50 and 85% of your receptors are binded to the aspirin drug itself, and that causes a therapeutic effect. And that's what we want to see. We want to see between 50 and 85% of the fish's amino acid receptors occupied, and that gives us that optimal stimulation, the so-called Goldilocks zone. So we've kind of moved from the macroscopic to the microscopic. We're now looking in terms of, hey, receptor site occupancy, Goldilocks zone, 50 to 85%, and we see it in the slide there. And as per the last slide, the gradient of the curve is extremely steep through that region. So once again, in the low concentration range and then through the mid-range, we're not going to see much in the way of stimulation. Now, the graphic I've just shown you there is for, think of a Goldilocks analogy, right? So the porridge is too cold, means we're in the pre-saturation region. We've just got maybe 10 to 20% of the sites occupied. In the graphic there, you can see it, the black hexagons are receptor sites, representative of receptor sites, and the green circles are amino acids. So 2 out of 9, we're way below 50%, okay? That's pre-saturation. And then the Goldilocks zone, there it is, right? So that's that magic window, very narrow, because we're filling up those receptor sites proportionally to concentration, right? We've now got 1, 2, 3, 4, 5 out of 9, so just a little bit over 50% of the sites filled. That's in the Goldilocks zone. That's what receptor site coverage looks like for low range optimal stimulation. Okay. Now think about that. Your bait's been dosed and it's leaking out amino acids from 0. You throw the bait in, none's gone out yet. Then it ramps through 0. So we all see this ramping effect in practice, right? And then before you know it, you're in an overdose condition. We're post-saturation. 9 out of 9 sites are filled. We see an overdose. We see the fish kind of get a little bit twitchy and just move off. And we're not going to catch anything at that point. So that again emphasizes that narrow window of optimal stimulation, which has always been a problem. But now we see it in terms of a physiological receptor site occupancy, which is important, right? Now, if you're still with me, how do we solve the problem? So back to our normal slide there, right? So that's our normal kind of response curve. Now watch what happens. I'm going to lower the curve. That's my magic trick, right? That's 20 years of research. How do I do that? Click again. Here it is, right? So the take-home message is, if I add a fixed fraction of blocking agent, now a blocker is simply a molecule that gets in the way of the active site. So it binds to the site, but it doesn't activate it. So we're talking super glue or chewing gum in a lock and you can't get the key in, right? So if I block 50% of the sites, then only 50%, the remaining, will be occupied. Therefore, I've lowered the curve. I'm now in a much, show you the picture, much broader concentration range for effective stimulation. And that is how the products work. We mix an amino acid of choice, which is somewhat species specific. We can pick and choose amino acids a little bit. We get our amino acid, we put in just the right fraction of PBA, proprietary blocking agent we call it, and that gives us optimal stimulation through an extended range. And that's the basis of how we've solved the problem. Okay, I hope that makes sense. All right, now, products and ranges. So let's talk about how we've applied this to a real product, right? So our first product, Impulse, which is a universal fish feeding stimulant. Turns out, a little bit of detail, there are 4 classes of amino acid. There's the acidic, basic, neutral, and polar side chain aminos, okay? And so fish have, therefore, 4 different types of amino acid receptor. Turns out that the basic receptor is pretty much at the same level in every single fish we've studied. Therefore, the same ratio of basic amino to blocker works for all species, and that's Impulse. Okay, so Impulse is a universal fish attractant / stimulant, works for, as advertised, carp, right? Species. So with, like, other members of the carp family, such as barbel if you're in the UK, or tench, as well as common carp, mirror carp. If you're in America, where I am, works great for all catfish species, particularly channels and blues. Okay. Also, believe it or not, works for trout and other salmonoids. And finally, even the most ancient fish apparently have basic amino acid receptors because it actually works really well for sturgeon. Lots of sturgeon charter captains here in Oregon and Northern California actually use it on their, their business operations, so that's kind of cool. All right, so Impulse works for everything, all right? Now, Catatonic, as the name may suggest, is a catfish-specific embodiment, right? Interestingly, catfish, aka the swimming nose, have more acidic amino acid receptors than literally any other fish. So therefore, for an optimal level of reception, if you wish, we have to add more blocker, right? So Catatonic is species-specific because it's a ratio of acidic and blocker, which is tuned only for catfish. So that's a species-specific embodiment. And finally, hey, what works for catfish works for carp. So if we lower the amount of blocker, right, it's now optimal for carp who have fewer amino acid receptors for acidic amino acids. All right, so that's how the theory works in practice. We now have 3 viable products which work great in both aquaculture applications. If you're, for example, looking for something to feed trout, salmon, even carp or catfish, wonderful, right? We can tailor you a product. If you're fishing, you want to catch anything, Impulse. If you're into carp, Cyprophil. And if you're into catfish, Catatonic. So those are our kind of flagship products at the moment, and it's currently summer 2026. Those are our current products. Okay. Finally, contact information. Aminotech Research and Development is our aquaculture arm of the business and has a website, aminotech.com, and feel free to email me directly at info@aminotech.com. And finally, biosource baits. If you're into fishing products, we do have a website where we sell directly to the public, but we also sell business to business. If you're looking to develop a bait, we have a complimentary consultation service. That's true for both companies. So consultation is free, complimentary. Drop us a line via the website and we'll be happy to talk to you. Okay. Any questions? Let me know. See you next time.